Hello everyone, in today's video we are going to see about Feistel cipher structure. So this is one encryption algorithm, okay, in which the plain text will be divided into some block of length, okay, and then we'll have one key, and for each block of the text there will be some process going on. So that complete process we'll be discussing in this video, and this complete Feistel cipher structure is very important question. Okay, so first let me just explain you what is this in brief, and then I'll explain you with the diagram. Okay, if I just make sure if I explain you like by reading these sentences you will not understand. This is only for writing the theory in the exams. So pause the video and write all these points, and listen to the concept when I explain with the diagram. Okay, so this Feistel cipher structure has complete 16 rounds. Okay, 16 rounds it will have, 16 rounds. And what happens is, first we'll have the length of the plain text. Okay, so this plain text will be divided into two halves. I'll explain it just a second. So what happens is, we'll have one plain text. Think this as a plain text. Now this plain text will be divided into two halves, left part and then right. Okay, you'll call this as in words. Okay, two words. Okay, two words, left and right. Now you will have one key. Okay, so now once this left and this right, and we'll have one round function. Okay, just remember the terms for now, we'll discuss in detail. What happens, this left and this right, they will get combined with the key, and then see from this right side, whatever the text which is on the right side, it will be appended with the key. Okay, and then this will be sending to the round function called f, and whatever the result we got here, we will send it to the left part, and there this result, whatever it is coming from the right side, it will get appended with the left part. Afterwards this resultant will be there, no, this will be sent to this side, and whatever the plain text we have here, I mean without appending the key and function, that will be sending to the left part. And this again same process will continues. How up to how many times? 16 times, because we have 16 rounds, right? So here each process, each thing is one round. Up to here it is one round. Now they have exchanged. So what happens here? XOR operation happens here. Okay, this part is there, no? What happens is, for example, if left thing is hello and right we have appended with key and then round function, and we got some z, y, x to v. Now for these two parts they'll convert to binary. Okay, binary, and then they will go for XOR operation. Okay, once XOR operation is done, we'll get some result, right? That will be transmitted to here, and whatever the plain text here we have in the right side, it will be done. Okay, first round output will be input to the second round. Okay, this is the basic thing whatever happens in the complete Feistel cipher structure. So first round output will be input to the second round. Okay, this is what happens in the Feistel cipher structure. It's clear, I guess. If not, please pause the video and listen to it again. I'll explain you in some time with clearly with the diagram as well. That why I explain you that, because that's a basic procedure how it happens in the complete Feistel cipher structure. Now let's make sure that we have some key terms in this also: block size, key size, number of rounds, sub key generation, round function, and fast software encryption or decryption, and ease of analysis. So all these things, all these terms will get in the diagram. I'll explain you there, and also you make sure that you will write all these points. Okay, pause the video and make a note of all these points. It will be useful for your theory part. Now this is the diagram which I have explained you till now. Like I have explained you one thing, right? You'll have 16 rounds. That is the basic. This is the basic. So see, plain text will be divided into left part and the right part. Each has W bits. Okay, W is some size. Now here whatever happening is XOR function, XOR operation will be happening. So what happens here, we'll get the right side part and we will append this right side to the function and the key. So here that function, see here round function means it's just some function. There we'll have some logic just to make sure that we are converting the plain text to some other form. And whatever the form we have obtained here, we will send that to the left part. So what happens here in left part, I said right, XOR function will happen. So it will happen here, this left part, left XOR right. Okay, we'll get some result, right, that will be sent to the right side, and whatever the right side here we have, it will be going to the left side. Now up to here one round is completed. Now the same process, whatever, like we are sending key to the right side part and we are calculating something logic using round function, and from this round function it will go to the left side, and again XOR operation will happen, and again the same, left will be sent to the right and right will be sent to the left. That means we are just doing cross operation. Okay, like that, how many rounds it will be done? 16 rounds. Okay, after 16 rounds again one final cross operation will take. That means 16 rounds is done, and for the last round they'll let's say here 16 round is done, we'll get the right part and left part, right? So we will not use function and key here. Okay, why? Because just a second guys, yeah, we will not use any function and the key here. We will just send the results from right to left and left to right. Okay, and whatever obtained here, we will just write it in a single sentence and we'll just make sure that is called as a ciphertext. This is the complete process of the Feistel cipher structure, which will happen in the 16 rounds. Okay, and now what happens is, this is a complete 16 round structure, right? Now I'll explain you each round structure in detail. We have 16 round structure and each round structure also. Okay, we'll see that now. Okay, now here what happens is, first okay, now what happens is we have input, right, plain text. Okay, now this plain text, this is for each round. Okay, I'm explaining you each round clearly. Up to here each round. Again this I have written that, we have the diagram for 16 rounds, but for each round also I'm telling you once more. You can use that diagram or this diagram also. What is the difference is, we have some labels clearly here. Okay, now input is given here, same left and then right. We are using the function here, we are sending using the key, and we are sending it here, XOR operation. Now again this is round 1. Now again we are using this function and key, we are sending to the right side and XOR operation, and then we are sending it here. So the difference between that diagram and this diagram is, you can get it out that here in the previous video we have just used XOR operation only on the left side, but why here on the right side? Because there we have crosswalk. That means, see, I'm sending the output of R to L and L to R, but here I'm not sending any output like that. That means there is no cross operation. So what is happening here? Left side will be on the left only, right side will be on the right only. This is just a different diagram. Okay, you can just listen video till there, previous, and this is the another way of representation. Okay, now since we are not crossing the left part and the right part, one time we are doing the XOR operation on the right side and the other time we are doing it on the left side. Why? Because see, if I'm keeping high, for just for your reference, high, I will send high to here. and some hello to here in the according to the previous video, and we will do the XOR operation for hello. But now here we are not sending the cross operation. That is why we are doing one time here for hi edit, and for hello, I mean whatever the result we got, it will be coming to the this side for the previous example. Here it is not coming. So we are just doing one time here and one time here. Okay. So if you feel this as a confusing diagram, just listen to the previous video only. I am trying to explain you in the other way as well, because you can just represent it in two-way format as well. So I'll tell you one more time this in the other way, just for your understanding. So what happens is, I'll draw two diagrams here. So in previous way, what happened, left part is going to right and then right again here to here. So it is like this is round, one round, R1, R2, R3. So here we are exchanging the result. That is why we are only using the round function on the left side. I mean XOR operation, sorry, not round function, on the left side. This is clear, right? And but here what happening is, even though we have left and right here, we are not sending the information left to right and right to left. Only that is the difference. That is why we are just shifting the XOR operation. Okay, here we are shifting the result, but here we are just shifting. So one time XOR operation here, other time XOR operation here, again XOR here, here. That is why we are sending function to here and again applying function to this and sending this to here. The same result only we will get, but only the process is different. I hope this is clear. If this thing is not clear, please go with the first thing only. Okay, if you are still not clear about these two parts, please comment in the video. I'll try to explain in some other way. Okay, this is the Feistel cipher structure, and this is how the complete process will go. So from the plain text to output, after 16 rounds we will get the cipher text. This is on the sender side. On the receiver side, what happens is, this cipher text will be given as input, and the same process goes and we will get the plain text again. Okay, that's all for this video. Thank you.